Good morning, students. In the last class we have discussed about the definition of matrices, and thereafter we have seen how to write a matrix of any order. Actually, there we discussed what is meant by the order of a matrix, and thereafter we had discussed how to write a matrix of order m by n. Okay, then now we have to come to classification of matrices. So means we have to come to different type of matrices. So we can say classification of matrices. So as the name says, in classification of matrices, we discuss or we consider different types of matrices. And when the discussion progresses, we can see that most of this classification are based on the order of the matrix, sometimes related to the speciality of row, sometimes related to the speciality of column, etc. So, among the different types of matrices, the first one we discuss is a row matrix. So the very definition of the matrix is very clear from the name itself. What is the name of the matrix? Row matrix. In the definition of the matrix, we have seen that a matrix is made up of rows as well as columns. It means in a matrix, there is equal importance to the concept of row as well as column. And here in our special type of matrix, the name we are giving is row matrix. So it is quite clear that instead of equal importance to the row and column as like a general matrix, here in the row matrix the importance is to row. And let us see what is that importance. And for that, it is better we consider an example. Suppose A is a matrix and A equal to matrix 1, 2, 3. So what is matrix A here? Matrix 1, 2, 3. And thereafter we write the order of the matrix. And in the last class itself we said it is quite convenient that we write the order of the matrix at the right bottom of the matrix. So anyhow, for writing the order, first we count how many rows are there. How many rows here? How many? Yeah, 1. And the columns, vertical arrangement, 1, 2, 3. So what does it mean? This is a matrix of order 1 by 3. We consider another matrix B. B equal to matrix A, B. And for the matrix A, the number of rows 1 and the number of columns 2. That is 1 by 2. Okay. And if you closely observe these two matrices, thereafter the orders of the two matrices, we can see that both the matrices have a common property when it comes to their order. And again remember, order means we think of which one? The number of rows and the number of columns. So can you say what is a common property for the two matrices? And I am giving you more hints related to the number of rows number of columns? Yes. The common property is both the matrices have only one row. That is, number of rows is equal to 1. So what does it mean? Here in the example, both the matrices have only one row, and such a matrix is more categorically known as a row matrix. Instead of having any number of rows, we are restricting the number of rows to only one, and such a matrix is known as a row matrix. So what is the definition? Simply, what is meant by a row matrix? A row matrix is a matrix having only one row. A matrix having only one row is known as a row matrix. Now, it is very clear as we discuss a row matrix. Of course, in the same manner, we will be coming to which one? A column matrix. And for saying the meaning or definition of column matrix, there is no need to make any elaborate explanation, examples like the previous one. Okay, row matrix means matrix having only one row. So column matrix means a matrix having only one column is known as a column matrix. So what is a column matrix? A matrix having only one column is a column matrix, or more classically, a column matrix is a matrix having only one column. So we can write an example. Okay, C is equal to matrix minus 2, 3, 4. Order is what? 3 rows, 1 column, 3 by 1. Another matrix D is equal to matrix PQ. Order is 2 by 1. So this way, a matrix having only one column is known as a column matrix. So in short, we have discussed what is meant by a row matrix and what is meant by a column matrix, and we said that a matrix having only one row is known as a row matrix, and a matrix having only one column is known as a column matrix. Okay, then related to row and column matrix, we just come to some correlation. For that, A equal to matrix 1, 2, 3. No doubt, this is a row matrix. B equal to matrix minus 1, 0, 5. Since it contains only one column, this is a column matrix. Okay, now we just concentrate on A. How many columns for A? 3 columns. How many rows for A? 1 row. So since 1 row, it is a row matrix. Now my question is the matrix A column matrix? Means, is the matrix A columns, whether A is a column matrix or not. For column matrix, we know the condition. What is the condition? There must be only one column, but 1, 2, 3. So what does it mean? A is a row matrix, but A is not a column matrix. Now we come to matrix B. How many rows? 1, 2, 3. So it is not a row matrix. How many columns? Only one column, so it is a column matrix. So if you consider the first matrix, it is a row matrix, but it is not a column matrix. And if you consider the second matrix, it is a column matrix, but not a row matrix. So what does it mean? According to example 1, a row matrix, not a column matrix. According to example 2, a column matrix, but not a row matrix. Okay, the meaning is, we have seen that a row matrix is not a column matrix, and a column matrix is not a row matrix. Now my question is, can we generalize this statement? Means, can we say that there is no row matrix that is not a column matrix? Otherwise, there is no column matrix that is a row matrix. Or in short, is it possible to find out a matrix that is a row as well as a column matrix? I am simply asking you, is it possible to give an example for a matrix that is a row matrix as well as a column matrix? Means it is row as well as column. So the answer for our search, the answer for our question is what? Yes, there is a matrix that is row as well as a column matrix. And what is that?